Hey guys. So, lesson number 12 here. We're actually going to dive right into the classwork. So, as always, notes first. If you haven't taken your notes, go back, get that taken care of here to kind of give you some perspective of what we're doing with here. But we're going to work through some of the classwork here together as a way to kind of discuss your inequalities. There's lots of little problems, and we'll be using this knowledge here in the next few lessons. So, the more we can just kind of get everyone on the same page and feel comfortable about it, the better off that we're going to be here. So let's get there. Lesson 12 classwork here. So we are in your classwork packet, lesson number 12. We're going to do some of these here. So first question, for each problem, using the properties of inequalities to write a true inequality statement. The two integers are -2 and -5. So they just want you to write a true inequality statement. So, all right, we're using the numbers -2. And we're using the numbers -5. So what do you say? Less than, greater than? All right. -2 is, yeah, it's greater than -5. Remember, the further you are to the right on the number line, the bigger that you are. Further to the left, smaller that you are. Now, we could have gone the other way as well, too. The idea here is if you chose to put your -5 first and then put your -2, then you would say -5 is less than -2. And this is one of the themes that we're going to see. It's when you flip the order, like how the -2 is first and now it's second over there. Well, it's going to end up flipping your inequality symbol. So we're going from a greater than symbol to a less than symbol. So let's see here. It says subtract -2 from each side. Okay, so a little tricky here. The wording here, subtract a -2. So that's really a double negative, which means we're actually going to be adding 2 to both sides. So if you take -2 and you add a 2 onto it, add a 2 onto, okay, all right, you get 0. Take the -5 and add a 2 onto it, you're going to get yourself a -3. So what do you think here? 0 is, yeah, no, 0 is greater than -3. Again, if we were the other way and we added on those 2's, we'd get a -3 here, we'd get a 0 here. -3 is still less than 0. So what we want to see here is if we're doing any sort of addition, which also means subtraction, it's not going to do anything to the inequality symbol. If you notice, we still had greater thans, and then in this order, we still had our left hands. So, all right, let's keep on going here. Now we're going to multiply each number by -3. So this is the question of like, hey, are we going back to the original? Let's go back to the originals, okay? Because we're not going to involve the 0 that's here. So if we multiply the -2 by a -3, so there's the whole idea is we had -2 is greater than -5. Well, if we multiply each by a -3, now we end up getting a +6 and we get a +15. So is 6 still greater than 15? No, it's not. 6 is less than 15. Watch what happens over here. Again, if we flip the order around, -5, all right, and we said it was less than -2. Again, if we multiply both sides by -3, that's a bad 3, isn't it? There we go. We're going to get a +15. All right, we're going to get a +6. Is 15 still less than? No. 15 is greater than 6. So the theme that we're getting away from here is what we saw in our notes is if you add or subtract, you will never mess with the inequality symbol. If you multiply and divide, okay, if you multiply and divide by a negative, you're going to flip your inequality symbol. And that's the theme. Add or subtract, positive, negative, we don't care. It's going to preserve the inequality symbol. But if you multiply or divide by a negative, then you're going to flip that inequality symbol. All right. Let's do this here. Let's go further down. What we're actually going to spend time with here is question 4. So it says if a is a negative integer, all right, then which of the sentences must be true below? If the number sentence is not true, give a reason. Okay, so first thing here is we're not going to worry about the given the reason here because we're going to solve this a little bit differently. What we're going to do is we're going to use our solving equation skills. And again, we want to see if a is going to be a negative integer. Let's look at part A here. To get a by itself, you are going to subtract 5 from both sides. So you're going to get a is less than 0. So if a is less than 0, does that mean it's a negative number? Absolutely it is. All right, then that is true. All right, we are dealing with a true, sorry, it's a very bad T here. There we go. That's a true statement. Let's go over to B. Um, to get A by itself, again, we're going to subtract 5 from both sides. So what we have left is we've got A is greater than 0. So if A is greater than 0, is it a negative number? No, it's a positive number. So that's going to be a false that we'll be dealing with here. I'm not sure why I put a T and then I wrote out the word false there. Anyway. All right, let's look at letter C here. Same theory here. We're going to get that 5 by itself, A by itself. We're going to subtract 5 from both sides. All right. So we're going to get negative A, and that's the key thing, is we got to keep that sign to the left of it, is greater than 0. Okay. But remember, when we solve our equations, we don't want to know about negative A. We want a positive A. So realize that there is a negative 1 that's in front of there. So we're going to divide both sides by a negative 1. And here's the thing we want to keep in mind is we just divided by a negative. What do you have to do with your inequality? Well, you have to flip it. So we're going to say A is less than 0. So again, we have to flip the inequality. It was a greater than symbol. We have to flip it and now it's less than. So if A is less than 0, does that make it negative? Absolutely it does. That's another true that's there. All right, let's go to letter D here. Again, you can see the themes that are going on here. It's the exact same problem in all 4 of these. We're subtracting 5 from both sides each time. All right, so negative A is less than 0. But again, we can't have a negative A, so we need to divide both sides by negative 1. Again, when you flip your inequality, when you divide by a negative, and that's what happened here. So we've got A is greater than 0. Does that mean it's negative then? No. So that means it's a false answer. All right. So again, solving your equation skills here. And again, each time we were looking, is A going to be a negative number? Let's get that there. Let's look at a few more of these. Letter E. All right, let's divide both sides by 5. So A is less than 1. If A is less than 1, are those all negative numbers? Well, most of them are, but not all of them there. Like a half. A half is a positive number. So that's not always going to be true. All right, that's not always going to be true here. So that's going to give ourselves a false statement. Divide both sides by 5. All right, so A is greater than 1. If A is greater than 1, is it negative? Nah, that's false. Let's go to letter G here. Again, get the 5, get the A by itself. So we're going to subtract. Ooh, wait a second. Ooh, this one's a little bit interesting because we got 2 letters that are there. Okay. Let's do this here. Let's think about this for a moment. If A is going to be negative, if you add a negative number, if you add 5 onto a number, will it always be bigger than what you started with? And that's what's going on here. If you add 5 onto a number, will it be bigger than what you started with? Absolutely it's going to be. Because anytime that you add a positive number on, you're going to move yourself further to the right on the number line, which is going to make you bigger. All right, so let's see here for letter H. If you add 5 on to a number, will it make it small? No, that's false. That's the exact opposite of what we just talked about. If you add 5 onto something, it's going to make it bigger. It's not going to make it smaller than it was. All right, let's look at this next one here. Letter I. If you take away 5, all right, if you start at 5 and then you end up taking away. What do you think here? What do you think? Well, let me show you the inequality that's here. You can see why we're kind of talking about this a little bit. Let me solve an equation. So the phrase here is combining like terms. We haven't seen this part of it yet. So if we add an A to both sides, just like with our numbers here, you're going to 5 is going to have to be greater than 2A. So not only can we move numbers, we can move your letters as well, as long as you do the same thing to both sides. So if we solve for A here, we divide both sides by 2, all right? we get 5/2 is greater than A, which means that A is less than 5/2. Are those all negative numbers? No, they're not. That's false. That's there. That's false. Let's go back up to letter G here, because one of the problems with the technique that we're using here, that I was using, is I was just trying to, like, well, let's just think about it. The problem with that is it doesn't take all scenarios into consideration. So let's look at this here, because there is something that's here. Again, if we use a negative number here, I don't want to explain it here. Oh, A has to be negative. We can't use 0 with it. Okay, yeah, no, we're fine. We're gonna leave it like that. Let's go down to letter J. My apologies. I thought I saw something there on it, but we're fine. We're fine with it there. And then the explanation of pulling in, if you add a 5 onto something, it's always going to be bigger than what you started with. So yeah, let's go down to letter J here. Again, let's use that equation idea here. So let's add an A to both sides. So we've got 5 is less than 2A. All right. Did you find my mistake on the previous problem? Did you? Were you thinking about that? Yeah, let's go back to that in a second. Let's finish this guy first. 5 is less than 2A. Divides both sides by 2. So I've got 5/2 is less than A. Again, that makes it false because they need to be negative. And, well, some of those are positives. Let's go back here. Did you see me flip the inequality symbol? See how it was a great... Oh, wait, was that okay? Was that okay what I did there? Like, I flipped the inequality symbol. Yeah, I flipped both sides. So as you can see here, I had the 5/2 on the left-hand side, then I moved it over to the right-hand side there. So because then I moved the A from the right-hand side and moved it to the left-hand side, I also flipped my inequality. All right, just in case you were thinking about that. I think that's kind of it of what we want to get to. I want to see what else was down there, if there's anything else worthwhile. No. The big thing here is what we're taking away. The big thing that we want to end up seeing here is, hey, if you multiply by a negative, you're going to have to flip your inequality symbol. If you divide by a negative, you're going to have to flip your inequality symbol around. If you add or subtract, you don't need to flip your inequality symbol around. And we kind of saw that here when we divided, but in part C and part D, when we divide both sides by -1, you had to flip your inequality symbol. We're going to spend a lot more time with this. Again, it's just your introduction that we've got for you. All right, guys, that's it for you. Yeah, we're done.